All right, so today we're going to look at the focus of a parabola. Now, in class, I'll talk about what the focus is, all right? But here, one question that you'll see is use the distance formula to write an equation of the parabola. Now, this is something that they used earlier, back in the day. Okay, so we know better ways to do it. So this is just so that we have practice. Okay, so a good way to do it is to graph it first. So let's make our coordinate plane. Oh, that's nice. Okay, and we have a vertex at 0, 0. Which way does it go? Does it open up or does it open down? The way we know is the directrix or the focus. Okay, so it opens up towards the focus, but away from the directrix. So our directrix is 1, 2, 3. It's right here at y equals 3. Okay, that's our directrix. So that means it's going to be opening down. And since our directrix is at y equals 3, our focus is going to be 0, comma, negative whatever the directrix was. So 0, comma, negative 3. So here's our focus. Okay, that's our F. All right. Now, the thing about the focus and the directrix is that we'll get, if you choose any point, okay, so let's choose this point right here. You go straight down to the, I know it doesn't look like it with my graph. Go there, and when we go to the focus, all right, if you use an actual graphing paper, then you'll see that these are going to be equidistant. Okay, so those are congruent, like you saw in geometry. So I'm going to name this one D, and it's going to be the point X, because we don't know what that X value is, right? But we know the Y is 3. How do we know the Y is 3? Because it says right there. And this point, we don't know this point. So this point is going to be P. It's going to be X, comma, Y. All right, so we have F, P, and D. All right, so what we need to know is that PD equals PF. Now, how do we find PD? Remember, we don't have any like line segment above it. That means we want to find the distance. So the distance of PD equals the distance of PF. So let's find the distance. Let's just focus on that PD first. Okay, don't worry about the PF yet. So the distance formula is absolute value of x2 minus x1. So let's do x. P is going to be, so P, so x minus x1 and squared plus y minus, so y2 minus y1. So y minus 3 squared equals, all right, so that's our distance formula for PD. Let's do our distance formula for PF. Same thing, square root, and x2 minus x1. We're going to let P be x2 again. So x2 is x, x1 is 0. Yay. So x2 minus x1 squared plus y2, or y minus y1, which is negative 3. So that negative 3 makes it a positive 3. No, do that later. Okay, so again, let's focus on the left side. So x minus x, 0. Hey, hey. So that cancels out. And here we get just y minus 3 squared. Now, I know that we get the y minus 3 squared by itself, and square root of that, I know that it can cancel out, but we won't want to do that yet. So let me write that down here. Y minus 3 squared. All right, now let's focus on this one. X minus 0 is x. So we have x squared. Y minus 3, so y plus 3 squared. All right. So now since we have square roots on both sides, now we can cancel them out. Okay, so basically we're squaring both sides. Okay, so squared and squared, you don't need to show it. So these cancel out, these cancel out. Bada bing, bada boom. We're left with y minus 3. Uh-oh. It froze.